Hi students, welcome to a Marvelous Math Monday. Here's what we were working on today. We were not working on the price of art, but I'll show you that to you in just a moment. We were working on factor trees. Factor trees are something we can do to integers. And integers, this is a type of number, an integer. It's a number like -3, -2, -1, 0, 1, 2, 3, and so on and so on and so on. And so on and so on and so on in both directions. Okay? These are our integers. It's not numbers like 5/7. That is not an integer because it can't just be written as one of these counting numbers in a negative or positive version. And we can factor integers. Factoring integers is super useful. And I'm not going to explain why. You just have to believe me. Okay, what does it mean? It means breaking this down as the ingredients that multiply together to make it, all of the different factors together. So first thing, let's test for divisibility by the primes, and we'll get a list of primes here. 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, and that's pretty much what we're going to need for today. Okay, 13, 17, 19, keeps going. Okay, now the first thing that I'll do is I can go through the primes and test them and see if this is divisible by primes. So I can test, is this divisible by 2? Yes, it is. It's an even number. So I can write this as 2 times 105. You can check that on a calculator and find that 2 times 105 is 210. Then I look at this one. Is it divisible by 2? No. Is it divisible by 3? How do I test for divisibility by 3? Well, all I need to do is add together the digits. And if the digits add together to give me something divisible by 3, it is divisible by 3. So when I test this, 1 plus 5 is 6. 6 is divisible by 3. Therefore, yeah, I can take a 3 out of that. And then maybe you need a calculator, and maybe you don't. But if you need a calculator, what you would do is you would write in 105. You would divide that by 3 to find 35. There it is, 35. Okay, so then I would write down this is 2 times 3 times 35. Okay, and then I want to test 35. Notice I don't need to test these. They're prime. They can't be divided by anything else. But 35, let's test it. Is it divisible by 2? No, it's not even. Is it divisible by 3? No, because 3 plus 5 is not divisible by 3. That would be 8. 8 is not divisible by 3. Is it divisible by 5? 35? Yes, it is, because it ends in a 5 or a 0, so it's divisible by 5. So now I can take out a factor 5, and I can remember from my times tables that 5 times 7 is 35. Now I can go ahead and circle all of my primes, and I could write that this is equal to, so I could say, therefore, 210 is equal to 2 times 3 times 5 times 7. Cool. That's the prime factorization of 210. Now, I could have done this a different way, and I'll do this quickly. I'll show you this example. Negative 210. Okay. First thing, well, I got a negative in there, so what do I do with that, Mr. Jennings? Well, how about we divide by -1? Let's take out -1 as a factor. Okay, cool. And then we'd be left with 210. Okay. 210 times -1 would be -210. So this is still working. All right. Now, I can break this one down even quicker. Watch. I notice that it's divisible by 10. Just take out your factor 10. This would be 21 times 10. And then I look at 10. 10 is 5 and 2. Those multiply to 10. 21 is 3 and 7. Notice it's the same. 3, 7, 5, 2. They just came out in a different order. So there is also the prime factorization of 210. Okay. Now, here's another cool thing that we can do, and I'll do another one for you here. I'll quickly do 72. So if I have the number 72, first thing I do is I notice that that's divisible by 2, and that's 36. 36 also divisible by 2, and that gives me 36 divided by 2 is 18. 18 also divisible by 2, and it gives me 9. 9 is not divisible by 2. No, what is divisible by? 3. It's 3 times 3, so there, we're done. All right, that's the prime factorization of 72. And I can write this as 72 equals 2 times 2 times 2 times 3 times 3. Boring. It's too long to write that out. So I have an easier way. Use powers. Mr. Jennings, what's a power? Well, I can write this as 2 to the 3 times 3 to the 2. Let's look at why. Okay. First, let's back up from this idea of 2 to the 3 and see what that means. If I look at 2 to the 3, that's telling me, this is a set of instructions that tells me take this number 2 and multiply it by itself 3 times. Okay, so that would mean 2 to the 3 is equal to 2 times 2 times 2. 2 multiplied by itself 3 times. Okay, now let's look at the parts here. This here is called the exponent. That tells you how many times to multiply. This is the base. It tells you what's being multiplied over and over again. And the whole thing is called a power. So these are our power rules. And we're breaking down our numbers into powers of primes. It's a really great skill to be able to have this, and we're going to practice it a lot. Okay, so now let's take a look here. 2 to the 3, that's 8. 3 to the 2, that's 9. 8 times 9 is indeed 72. So that's another way of looking at it. Okay, cool. Now, we can also do this to numbers in scientific notation. All right, we can ask ourselves, first of all, is that an integer? Well, integers are numbers, just to review. Integers were our numbers like -3, -2, -1, did not include decimals, did not include fractions. 4.2 is a decimal. But what happens when I multiply it by 10 to the 5? Okay, well, here we have to do Bedmas when we're expanding these things, but it's really easy, and I'll show you how. First, I'm just going to rewrite what I have here in the same way. 4.2 multiplied by, the first thing I have to do is the exponent. I don't do this multiplication first because Bedmas. Brackets first, then exponents, then multiplication and division in either order. Okay, so first I'm going to do this 10 to the 5. So that'll be 10 times 10 times 10 times 10 times 10. Okay, 4.2 times all of those 10s. Well, what are all those 10s? When I'm multiplying 10s, I just add the zeros. 10 times 10 is 100, 2 zeros. 10 times 10 times 10 is 1,000, 3 zeros. 1 0 per 10. So let's do that. 4.2, didn't change that, times 1 with 5 zeros. 1, 2, 3, 4, 5. It's 100,000. This is 100,000, okay? So this is 420,000. So here we go. 420, comma, 000. There we go. Now, can we prime factorize this? Yes, we can. But I'm going to do it in the easy way of taking out the powers of 10 first. Basically, I'm just going to write this, except without the 4.2. This is the same thing as saying 42 times, well, that would be 1, 2, 3, 4 zeros. 4 zeros, so that would be 10,000. Where did that extra zero go? Well, it's like one of these 10s got eaten up, turning 4.2 into 42. See, this is an integer. That's not. But this here, this is still an integer. Just because I have to multiply it out to find out what it really is. Okay, so 4.42 times 10,000. Now, let's do this one first. 42, well, that's divisible by 2, gives me 2 times 21. 21 is not divisible by 2, but it's divisible by 3 and 7. I'm just going to circle my primes, 2, 3, 7, and now I'm going to get this one apart. Well, 10,000, well, that's like 10 times 10 times 10 times 10 times 10. Big spider web of 10s. 5 10s coming off of that guy. And then each 10 is just 2 times 5. So this is 2 times 5. 2 times 5. In fact, I'll have 5 2s as factors and 5 5s as factors. And I wonder if you noticed the pattern yet. Okay, so there's all my 2s and 5s. Now let's count them up and find what the prime factorization of 4.2 times 10 to the 5 is. Okay, well, we find how many 2s? 1, 2, 3, 4, 5, 6. So 4.2 times 10 to the 5 is equal to 2 to the 6. 2 multiplied by itself 6 times, times 3 to the, there's only one 3, so I could write 3 to the 1, or I can just write 3, because 3 times itself one time is 3. So 3 to the 1 is 3. Anything to the 1 is itself, times 5 to the how many? There's 5 tens, so there were 5 factors of 5. 5 to the 5. Okay. Now, I could also have written this as 2 times 3 times 7 times 2 to the 5 times 5 to the 5. This was 10 to the 5, and it factored down into 2 to the 5 times 5 to the 5. So there's my prime factorization of 4.2 times 10 to the 5. So that's how we can factorize big scientific numbers very quickly. And that's going to help us do our division and our addition and so subtraction and multiplication fast, and even in our heads when we get good at these rules. All right, everyone. So thank you for tuning in for your learning. I will leave the work that we did in class in the email as well, so that you can try that out and get practicing with that tonight so that you don't miss anything and can stay caught up. Bye for now, everybody. Oh, actually, let me talk about this piece of art, price of art business. So here's a PowerPoint that was clearly made by a student at some point, and they were using scientific notation to show the price of different artworks. So here is a famous one. The Card Players sold for $250 million. That'd be the same as 2.5 times 10 to the 8. We should close that bracket there. It's weird that they don't. So that's just moving the decimal place 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool, eh? And then here, another famous one, the Scream, sold for 1.99 times 10 to the 8. So we can't see it there, but that's 199,900,000. Yeah, and it's moving the decimal place 8 times. That's the trick with these scientific notations. You just move the decimal place as many times as it says. What's the next one? So here, so we expect this one to be 3.065, and it is times 10 to the 8, because they all have the same number of digits. So that's going to tell us what this is doing here, how many times we need to move that decimal place. Okay, and this is just a multiplication. Scientific notation is just multiplication and bedmas, but it's a very efficient way of writing numbers. All right, everyone, thanks for showing up for your learning and staying with me up until this point. The work will be in the D2L. Bye for now.